For question 2, we have this interest rate of 5%, and then for the first 4 years, we're receiving 1,000 at the end of each month, and then later on, we're receiving 2,000 at the end of each quarter. So a quarter means 3 months, and it lasts for 6 years. So as always, we draw a diagram to visualize what's going on. So it lasts up to 10 years, and there's an interest rate of 5%. And for the first 4 years, we're receiving $1,000 per month. And for the final 6 years, we're receiving $2,000 per 3 months. And it's all happening at the end of each period, so it's all annuity immediates. So what's the present value? So we just break this up into 2 parts. So let's consider this first case over here, the annuity immediate for the first 4 years. So there are a number of formulas you can use. You can use the one with the bracket on top, but I just like memorizing formulas. So all I'm going to do is just find the effective rate per month and to apply the annuity immediate formula directly. So if we're treating a month as a period of four years would translate to 48 months. So there are 48 payments. It's going to be all this is going to happen at an interest rate J. So this J is going to be the effective rate between each month. And so using this, we can find J. So J is just equal to 1.05 to the power of 1 over 12 minus 1. So this is just converting from the effective rate per year to just a month. So that's all that is. So you can just substitute it directly into this part, and then you'll get the present value of all the payments within this period. And then we do the same thing over here. So there are 6 years, and so there are 4 periods of 3 months in a year, so it's a quarter. So there are 4 payments per year. There are 6 years, so there are 24 payments. And now all this is going to happen at an interest rate of k, and then we do exactly the same thing as we did. Only this time k is the effective rate per 3 months. So all we have to do is just to take 1.04, raise it to the power of 1 over 4 minus 1. So this is our k. So all this would give us the present value of all the payments here, and it will give us a current value as we are standing at time 4. So all we have to do is just to take this back to time 0. So we divide all this by 1.045 to the power of 4. And then you just plug everything into your calculator. For this expression, you'll get this answer. And then for these other payments, you'll get this expression. And then add them up, you'll arrive at the answer. So this method differs from the suggested solution. So I just like memorizing formulas. So that's why I think converting everything into the effective rate and then just applying the normal annuity formula is the easiest for me.